Imagine an ancient city thriving in a dry landscape, needing a constant, clean supply of water to sustain its people, its baths, and its agriculture. The challenge was immense. How do you transport millions of gallons of water over many miles, often across valleys and uneven terrain, using only the technology available thousands of years ago? The ingenious solution created by the Romans, which allowed their aqueducts to stretch across vast distances with remarkable stability, revolved around one brilliant structural element. Roman aqueducts achieved their incredible stability and longevity through the sophisticated use of the arch, specifically the semicircular arch. This structural innovation allowed the aqueducts to carry immense weight while efficiently distributing forces downwards and outwards, making them incredibly strong and resource efficient. The fundamental principle behind the arch's strength is compression. Unlike a simple beam that experiences bending and tension, an arch converts downward vertical loads into outward horizontal thrusts. Each stone, or voussoir, in the arch is wedge-shaped, and when weight is applied from above, it pushes these stones together. This tight interlock creates a stable structure where all forces are transferred through the material in compression, which stone and concrete are exceptionally good at resisting. To construct these arch supports, Roman engineers would first build a temporary wooden framework called a centering. Stones or concrete segments would then be carefully placed over this centering, starting from the abutments or side supports and working inwards. The final critical stone to be set was the keystone at the very top, which locked all the other voussoirs into place. Once the keystone was inserted, the centering could be removed, and the arch would stand self-supporting, ready to bear the weight of the water channel and subsequent arches. Beyond just their strength, arches offered significant advantages in construction logistics and material economy. Building a solid wall across a valley would have required an astronomical amount of stone and labor, and it would have been highly vulnerable to foundation shifts. By contrast, a series of arches created an elevated arcade, which required less material and significantly reduced the structural load on the foundations. Furthermore, the standardized dimensions of these arches allowed for repetitive construction processes, speeding up large-scale projects and enabling vast networks of aqueducts. The integration of the semicircular arch into aqueduct design was more than just an engineering feat. It was a cornerstone of Roman civilization's ability to flourish. This structural solution not only ensured a reliable and continuous water supply for centuries but also minimized material waste and maximized construction efficiency. Understanding the power of the arch helps us appreciate how Roman engineering transformed landscapes and profoundly shaped urban life, leaving a legacy of durable infrastructure that still impresses us today.